Hi, my name is Vivian Owens. As an environmental science major, I hold a large interest in the ways in which improvements to our environment can also improve human health. So, for my practicum project, I worked with UMD's Soil Quality Lab on their nitrogen cycling project. The lab is run by Dr. Ray Weil, who is a soil science professor in the University School of Agriculture and Natural Resources. Dr. Weil has multiple ongoing projects dealing with the movement of key plant and soil nutrients in the ecosystem, but I'm a part of the team dealing with the issue of nitrogen leaching. Nitrogen is a highly water-soluble element found naturally in many places around the world, including vegetation, soil, and groundwater aquifers. Rain and irrigation of cropland causes the nitrogen in the top layers of the soil to travel down into the groundwater, polluting it. This can create an issue for families that live off of well water, as they rely on the natural filtration capabilities of the soil and rocks below. Consuming too much nitrogen can cause hemoglobinemia, an illness where excess nitrate in the body inhibits the blood's ability to carry oxygen, and can cause the skin to turn blue with cyanosis. Other health risks associated with the overingestion of nitrate include increased heart rate, nausea, headaches, abdominal cramps, and increased risk of cancer. In order to combat this public health issue, our study was designed to decrease the amount of nitrogen making its way into the groundwater by implementing a mixed cover cropping system. A cover crop is a specific type of plant grown in the off-season of corn, wheat, barley, and other types of cash crops. There are many different plants that can be utilized as a cover crop, but typically they are chosen for their ability to absorb large amounts of nutrients. Our study used a mixture of radish, rye, and clover plants as the cover crops. The radish is capable of holding large amounts of nitrogen and has long roots that extend deep into the soil, drawing nitrogen into itself. As our off-season was during the winter months, the rye and clover, which have shorter roots than the radish, were chosen because they are both hardy winter crops. A radish is essentially the vegetable version of a watermelon, all water. When the radishes are killed, typically by the late January, early February frost, they release their water, spilling all of the nitrogen that was trapped inside of it back into the topsoil. The rye and clover are then able to draw the nitrogen into themselves, trapping the nutrient once again. When it comes time to plant the cash crops, the cover crop is killed using an herbicide, but not harvested off the field. That way, as the rye and clover decompose, any nitrogen the plants were able to hold onto will be returned back into the soil for cash crops to take up and use for their own growth. The goal of the system is to never allow excess nitrogen to stay in the soil, where it could be leached down into the groundwater. In order to test the effects of the mixed cover crop system, the lab planted 4 different treatments. The first was a no cover crop treatment as seen on the top left picture. Once the cash crops were harvested, nothing was planted in this section of the field. The picture directly under that shows the just rye treatment, where only rye seeds were planted. The top right picture depicts the treatment that only consists of radishes, and the pictures under that shows the final treatment of all 3 cover crops together. Throughout the winter season, many different samples such as plant, soil, and soil water were taken at various stages of plant growth. Each sample was tested to see how much nitrogen it contained. As this research is ongoing, I do not have the access to the results yet, but ideally the progression of plant growth would show increased levels of nitrogen in the plant samples and decreased levels of nitrogen in the soil and water samples. Cover cropping is a widely used method around the world, but mixed cover cropping is a fairly new concept. The success of this research can lead to future protocols on off-season cover cropping that will not only benefit ecosystem health, but human health as well. I greatly enjoyed working on this project, and it inspired me to pursue a degree in soil science. In the future, I plan on continuing my work with Dr. Weil's lab, as he will be starting new projects this coming fall. I want to thank Dr. Weil and his PhD candidate Nathan Sedshi for inviting me onto the team and educating me in the ways in which environmentalists can benefit human health. I would also like to thank all of my coworkers for helping to train and encourage me to participate in this research study. And of course, a huge thank you to the GPH program staff for all that they do to support my fellow GPHers and I.